This massive industrial facility produces millions of stackable potato chips every day using a unique manufacturing process. While traditional chips are sliced, these uniform crisps begin as a mix of dehydrated potato flakes. Dried potato flakes are poured into the hopper, serving as the primary base ingredient for the recipe. Cornstarch and rice flour are added to the potato base to improve texture and structural integrity. Precise amounts of water are sprayed into the dry powder to begin the transformation into a dough. Large industrial augers churn the wet mixture, hydrating the starch molecules to create a dense, malleable mash. The mixture exits the machine as a continuous log of dough, ready for the high-pressure sheeting process. Conveyor belts transport the dense potato dough toward a series of heavy steel rollers for initial flattening. Hydraulic rollers compress the raw material with immense force, turning the log into a wide, flat sheet.
A second set of rollers reduces the thickness further, ensuring the sheet is perfectly uniform and smooth. The final dough sheet is rolled until it is thin enough to allow light to pass through.
The continuous sheet travels under a rotary cutter drum that punches out hundreds of oval shapes instantly. The
sharp metal dies cut the distinct oval patterns that will eventually form the iconic curved chip shape.
The excess dough web is lifted away from the conveyor, leaving only the perfect oval cutouts behind. This scrap material is immediately transported back to the mixer to be reused, eliminating any food waste. The flat, raw chips move onto a separation belt to ensure they are properly spaced for molding.
Each flat oval drops into a specially shaped metal saddle, which imparts the famous hyperbolic paraboloid curve. A top mold clamps down gently to hold the chip in place, preventing deformation during the frying process.
The clamped chips travel directly into a massive tank of boiling vegetable oil to cook and harden. They remain submerged in the hot oil for exactly 11 seconds to achieve the perfect golden crispness. Sensors monitor the oil temperature constantly, as slight fluctuations could burn the thin chips or leave them soggy. The molds emerge from the fryer, and the excess oil drains away from the now rigid potato crisps. The top clamps release, revealing the cooked chips, which have now permanently taken the shape of the saddle.
Gentle jets of compressed air blow the chips out of the metal molds and onto a wire conveyor.
The empty metal molds loop back underneath the machine to receive the next batch of raw dough ovals. The hot chips pass through a curtain of seasoning powder, which adheres instantly to the residual surface oil. A rotating drum gently tumbles the crisps to ensure the flavor coating is distributed evenly on both sides. Different production lines utilize specific spice blends, such as the red paprika mix used for barbecue flavor. Other lines apply green speckled powders for the sour cream and onion variety, requiring strict allergen separation. The seasoned chips move onto a vibrating conveyor belt that spreads them out for a visual quality inspection. Workers manually inspect the stream, removing any broken or burnt chips that do not meet quality standards. Digital cameras also scan the line, using air jets to blast away any defects missed by human eyes. The chips approach the stacking zone, where they are flipped over to ensure they nest together perfectly. They are arranged into an overlapping stream, resembling roof shingles, which allows for high-speed automated stacking. Guide rails gently push the overlapping stream together until it forms a solid, continuous log of chips. This horizontal log of seasoned potato crisps is now ready to be separated into individual portion sizes. Mechanical separators divide the continuous log into specific lengths that correspond to the standard can height. The separated stacks are guided into vertical chutes, preparing them to be inserted into the cylindrical packaging. Empty cardboard composite cans travel along a high-speed conveyor, arriving just in time to meet the chips. Before filling, each can is inverted and blasted with ionized air to remove any potential dust particles.
The stacks of chips are gently slid vertically into the cans, maintaining their alignment to prevent breakage.
A mechanical plunger lightly taps the top of the stack to ensure the chips are seated at the bottom. The filled cans pass over a check weigher that instantly verifies the net weight of the product. Any can that is underweight is automatically kicked off the line to ensure the customer receives full value. The approved cans move to the sealer, where a tamper-proof aluminum foil membrane is applied to the top.
A heated element presses the foil onto the can rim, creating an airtight seal to preserve freshness. Plastic lids are snapped over the foil seal, allowing the consumer to reseal the can after opening.
The sealed cans pass through an X-ray machine to detect any foreign objects or broken chip fragments. The cans are accumulated into groups of 12 or 24 and pushed into the automated case packer.
Cardboard sheets are folded around the grouped cans to create a shipping case that protects the product.
The boxes are sealed with heavy-duty tape and labeled with shipping information for logistics tracking.
Robotic arms lift the heavy cases and stack them onto wooden pallets in an interlocking stability pattern. The full pallets are wrapped in stretch film to secure the load for transport to distribution centers. Forklifts transport the pallets to the massive warehouse, where they await shipment to retailers around the world. In the quality assurance lab, technicians test the structural strength of the chips to ensure transit durability. The curvature is measured with precision calipers to guarantee the chips will stack perfectly without any gaps.
Sensory panels taste samples from every batch to verify the flavor profile matches the specific recipe standards.
Chemists analyze the oil content to ensure the chips are not too greasy and meet nutritional labeling. Regular maintenance of the rotary cutters is essential to keep the edges sharp and the shapes clean.
Sanitation teams perform deep cleaning cycles on the stainless steel equipment to maintain strict food safety hygiene. When switching flavors, the production line must be purged and cleaned to prevent any cross-contamination of spices. The factory also runs separate lines for smaller single-serve cans, using the same chip, but shorter tubes.
Cardboard waste from the packaging process is collected and baled for recycling, minimizing the facility's environmental impact. The raw ingredient silos are constantly refilled to support the continuous 24-hour operation of the production lines.
Plant managers monitor real-time efficiency graphs to optimize the speed of the dough sheeting and frying processes.
The unique texture of the chip surface is a result of the precise moisture evaporation during frying. The engineered structure provides a consistent crunch that does not shatter into sharp shards when bitten. This standardized process allows the company to produce dozens of different global flavors using the same base. Trucks depart the facility carrying the finished goods to distribution hubs and supermarkets across the entire continent. For international markets, the cans are packed into shipping containers and exported to over 100 countries. Retailers stock the rigid cans, which protect the product from breakage far better than traditional chip bags. The distinctive packaging has become a marketing icon, instantly recognizable to consumers in any language or region. Opening the can involves popping the plastic lid and peeling back the foil to release the aroma. The cylindrical design allows users to reach in or slide the stack out for easy sharing. The saddle shape is ergonomically designed to fit the tongue, maximizing flavor contact with the taste buds.
Unlike bagged chips, which contain mostly air, the stacked crisp offers a much higher product density.
Mathematicians describe the shape as a hyperbolic paraboloid, a geometry that prevents cracks during the stacking process.
The design was patented in the 1960s to solve the problem of broken and greasy chips.
The machine required to produce this shape was engineered by Gene Wolfe, who was also a novelist.
The inventor of the can was so proud that he requested his ashes be buried in one.
Today, the legacy continues in high-tech factories that have optimized the speed and efficiency of the line. Automation handles the complex task of sorting different flavors into variety packs for the wholesale club market.
Limited edition runs allow the brand to experiment with unusual holiday flavors without disrupting the main production. Air filtration systems keep the factory environment free of potato dust, ensuring a safe workplace for employees.
Water used in the dough mixing and cleaning process is often treated and recycled on the site. Modern facilities utilize energy-efficient lighting and heat recovery systems to reduce the carbon footprint of manufacturing.
The human workforce remains vital for overseeing the automated systems and ensuring the quality never wavers.
The marketing slogan regarding the pop of the lid highlights the freshness sealed into every single tube.
The transformation from a wet potato mash to a crisp, golden chip takes less than 20 minutes.
This speed ensures that the potato flavor is locked in before the product is sealed for shipment.
The mustached mascot on the can has evolved over decades, but the chip inside remains largely unchanged.
The uniform shape allows for playful interactions, making the food more than just a simple salty snack.
It is consumed in over 140 countries, bridging cultural gaps with a universal love for potatoes.
As the sun sets, the factory continues to hum, driven by the global demand for the product.
The logistics network never sleeps, ensuring that store shelves are restocked before the morning customers arrive.
From a simple potato flake to a geometric marvel, this process redefines the modern snack food industry.
This has been an inside look at the engineering and science behind the world's most stackable chip.
For more deep dives into industrial food manufacturing and engineering, be sure to subscribe to this channel.
Thank you for watching this detailed exploration of the technology that powers the modern potato chip factory.